So now we have a lot of differentiation rules that have been presented to allow us to find the derivative of many functions. But there are still some functions for which those rules are going to be inadequate. For example, if we have the function f of x and g of x cubed and g of x phi x plus 4, we can make the composition of functions f compose g, and that's going to give me the function phi x plus 4 cubed. Now, with this function, one way is to expand what the binomial cube is. And so phi x plus 4 can be expanded in a very big polynomial, and then at the end we take the derivative of that. And that is fine for something like a cube. Unfortunately, if we go further and we get something like phi x plus 4 to the 100, the break in the polynomial is going to be so big that we just need a better approach. That approach is going to be called the chain rule. So the idea of the chain rule is that you assume that you have a function y equals f of u, where u is actually another function g of x that is differentiable at the point x, and the composite function is going to be a differentiable function at the point x. And so the derivative is this, and it can be expressed in two different ways. The first one is using the Leibniz notation, which is we have the function is y, so the derivative of y with respect to x is equivalent to the derivative of y with respect to u times the derivative of u with respect to x. Or we consider the composite function, and we take the derivative of f composed g, and that is going to be f prime composing g times the derivative of g. Okay? Or essentially, we take the derivative of the main function, compose the original g, and we multiply it by the function in the inside, which is g, and we take the derivative of that. Okay? So let's summarize that in certain steps. So assume that you have a differentiable function y equals f of g of x, right? We're going to identify who's the outer function and who's the inner function, and we're going to let u equals g of x. And that way, then we're going to replace now g of x with u to express the function y just in terms of u. Then we can calculate what is the product, the y du times the u dx, and replace u with g of x at the end in the y du to obtain the y dx. Sounds like a lot of the steps? Yes. So let's take a look at some examples and how to do this. So first, we're going to have the function phi equals phi x plus 4 to the 3/2. Okay? So I can identify who the functions are. So I can say, well, if this is supposed to be certain f composed g, clearly the function f of x, or let me call it f of u, is going to be the function u to the 3/2. Okay? U to the 3/2. And now the function g of x is going to be the function phi to the x plus 4. Okay? And so notice that the composition between these two, between this function and this function, is going to produce f of g of x. Well, assuming that we keep that order, f of g of x, and it's going to produce this phi of x plus 4 to the 3/2. Now, if we're doing this, notice that this is the function y equals f of u, and this is the function u equals g of x. So we can take the y du, and the y du is just going to be the derivative of u to the 3/2, so it's 3/2 u to the 1/2, which is the derivative of this. And we can also find out very easily what is the u dx, since this is 5x plus 4. So notice that this is just going to be 5. So now the chain rule, which is the derivative of y with respect to x, is by the formula the y du times the u dx. Okay? And so we have those two things. We have the y du, which is 3/2 times u to the 1/2, and times the u dx, which is 5. So we have 15/2, and that part's fine. But now what we can do is we can replace what is actually u. We know that u is 5x plus 4, so we get 5x plus 4 to the 1/2. Okay? And so this is one way of doing this. Okay? The other way is once that I identify who f and g are, then I use just the other formula. So let's take a look at an example of that. Now let's do it with the function y equals sine cube of x. Clearly you can see the composition here. The function f of x is x cubed, and the function g of x is sine of x. So clearly if we compose f and g, is essentially gx cube, right? And this gx cube is going to be sine of x cube, which in turn is going to be sine cube of x. Okay, so identifying who the functions are is key to the chain rule. Once that you identify that, then you can just play with the formula. Remember, the formula of the chain rule says that if y equals f of g of x, then y prime is f prime of g of x times g prime of x. So since we identify who f and g are, we can very easily find out who f prime is and who g prime is. And so notice that we can go back and do that composition. Now f prime is 3x squared, so we have 3x squared composed in g, so 3g of x is squared times g prime of x. But g prime of x is going to be the cosine, so here we get to replace what g and g prime are. So g is sine of x, and g prime is cosine. So we can simplify this as 3 sine squared cosine of x. Okay? So notice that this is like I'm taking the derivative of a power over this function. So I put down the 3. Now this becomes a 2. And then what I'm multiplying outside is by the inside function derivative. So by the derivative of the sine. Let's take a look to one more example. Notice the difference if I do the other side composition. So if I have sine of x cubed, now notice this is different from that. In this case, the function f of x is going to be sine of x, and the function g of x is going to be x cubed. So that way, f composed g is the sine of g of x, or the sine of x cubed. Okay, and so using the formula we have, okay, so f prime is cosine and g prime is 3x squared. So now if we do y prime, we get f prime of g times g prime, and that's going to be f prime is cosine, so cosine of g of x times g prime of x. And so now cosine of g of x, which is x cubed, times g prime of x, which is 3x squared. Okay, so now the main derivative is the cosine. The main function here is the cosine, so we do derivative of the cosine times the derivative of the function inside, which is 3x squared. Okay, and so that's the basics of how the chain rule is operating. Now, before I jump into the next part, let me just do the same example, but using the other notation, using the Leibniz notation. Okay. So let me have this here, and so I'm going to have f of u to be sine of u, thinking in that way, and now u equals g of x is going to be x cubed. So it's the same way of seeing this, but now I can calculate, this is y, so I can calculate the y du. The y du is the derivative of y with respect to u, which is cosine of u, and I can also calculate the u dx, which is the derivative of u with respect to x, which is 3x squared. And so notice that the y dx, which is what I want, is just the multiplication of these two things, the y du times the u dx. And that is going to be cosine of u times 3x squared, which is essentially the same thing. Now notice that u is x cubed, so cosine of x cubed times 3x squared. Okay? So two different ways of arriving to the same result.